so what do we remember about absolute value? We're dealing with second day of compound inequalities. A lot of absolute value on here. What do you guys remember about absolute value? Really?
It's the distance number is from 0 and
Good. It's the distance a number is from 0 on a number line. Anything else? Yeah? Okay. An absolute value has to equal a positive, so your distance always has to be positive. Anything else? Okay. How many remember the 3 steps to solving an absolute value? Anyone remember the first thing you have to do? Annalie? Good. The first thing you have to do is to get the absolute value by itself. All right. So if you're making yourself just some notes, if you didn't remember that, number 1, get the absolute value alone. So when I say get the absolute value alone, I mean get these symbols and what's inside them. So there could be a lot inside them. There could be a whole bunch of stuff inside, but get the symbols by themselves on one side. Okay, so get the absolute value piece by itself on one side of the equation. All right. So on number 16, are we good here? Yeah, absolute values alone on this side, right? It doesn't matter what's inside. Number 19, are we good there? Yep. Remember, it doesn't matter what's inside. It's like cleaning up the yard, remember? It's like take whatever's on the outside of the absolute value. If this was our house, we don't care what's on the outside of the house. Or on the inside of the house, it's what's on the outside. You got to clean up outside. Okay, so this is good. Okay, how are we here? Good? Not good? What do you guys think? Good? How about here? Good or not good? Not good, okay? So this one doesn't matter what's in the house, but here we have something outside, right? So we got to move that 2 over. We have to add 2 to both sides. Okay, so now we have that absolute value of j is greater than or equal to 8. So now we're good there. Okay, so you have to kind of clean up the yard or clean up the outside there. Okay. Second step, second thing, does anyone remember what it was? It's called a positive and negative case. So we want to do our positive and negative cases. And what that means, so you might have a different way of expressing this after we talk about it again. But remember, what that means is if you're looking, say, at number 16, it says express each absolute value inequality as a compound inequality, then solve and graph the solution on a number line. Okay, well, a compound means more than one answer. And if you remember, when we're thinking absolute value, we're thinking distance from 0. And let's just ignore the inequality symbol for a minute and just think of it as like a number line. Okay, on a number line, if I had 0, there are 2 numbers that are 2 units away from 0. One of those numbers is 2, and the other one is -2. So whatever is inside the absolute value here, whatever's in there has to give us a negative case, which would be -2, and would be a positive case, which is 2. Those are our 2 cases. So that's our negative, this is our positive. Okay? Now on this, that's our inequality symbol, right? That goes with this one because it's already positive. When I make a negative case, it's like I've changed that from a positive to negative. It's almost like I've multiplied it by -1, which would mean I'd have to flip my sign on that one. So on your negative case, flip the sign. Okay, so we've almost expressed it as a compound inequality. We have 2 answers. We have 2 different rules. My question is that an and or an or equation? Okay. Go ahead and talk with your neighbor about it. Tell them why you think it is what it is. I think it's an and. I think it's an or. Good. Why is it an or? Mackenzie? They're going in opposite directions. So if I were to graph it, that would be open circle, that would be open circle. That one shades that way. That one shades that way. They go in opposite directions. Good. Okay. So there's no way to possibly have two answers that are the same, right? I mean, or so there's no possible way to come up with a number that would satisfy both of these solutions. Okay, you can't have a number that's less than -2 but greater than 2. It's not possible. It's an or. The other way, well, actually, let's look at number 19 first. Okay, I want everyone to, we've already got the absolute value alone. I want you to set up your cases there. Number 2. Or number 19, I guess, not number 2. Okay, on the number line, how many units from 0 am I? 2, right? So that means the thing inside our house, or inside our absolute value here, has to be 2 units from 0. Means the s plus 4 has to be 2 units from 0. So it could be a positive 2 if we went this way. So if we moved away, it could be positive 2. And our s plus 4 could, our thing inside the absolute value, could also be -2. So we've got our positive and our negative cases right there. Alright, so that thing in here just drops out, and you put your negative and positive. So if it's going to equal or be -2, remember our symbol flips on our negative case. If it's going to be -2, what do we get? S is greater than -6. Okay. How many got that one? All right. And here, if it's going to be +2, flip it around. Okay. And we get x is less than -2. Okay. How many got those 2? All right. Is this an and or an or? Who says and? Who says or? Who says I'm not sure? Okay. Let's check. You set it there, that's fine. If I have -6, I got to put -6. I'm going to move it over here. Here's my -6. It's an open circle. Here's my -2. It's an open circle. Okay, -2 is shading this way. -6 is shading that way. That's an and. Okay, that's an and. All right, so if I'm writing this out, I could write this and this. Those are my solutions. So we've got to have our inequalities, our solutions written out. There we've got them. You could also, since it's an and, you could have said s, -6, -2. Make sure your arrow's pointing at the -6. Make sure your arrow's pointing at the s. You could have wrote it like that since it's an and. Remember, ors you can't write like that. All right. Any questions? Think we got them? Okay. Here we go. Okay, so in the back, problem number 24. Take a look at that one. Problem number 24 is the absolute value of W is less than -4. All right. Can anyone tell me why that's a problem? Go ahead, Annalise.
Because the absolute value is the answer can't be a negative.
It can't be a negative. Now, it for sure can't be less than a negative, right? Like, if an absolute value, so if this was equal, if rather than having the inequality symbol of less than, we had equal, we know it can't equal a negative. So pay close attention, guys. I won't take a lot of your time here. Just pay attention. If we know it can't be equal, can it be less than? It can't be less than. Could it be greater than a negative? Yeah, absolute values can be greater than a negative. Can't have secret agent stuff in right now. Yeah. getting messages from the secret agents. Keeping me safe. That's good. Thank you. Okay. We can have it greater than a negative. All absolute values are greater than negatives. They're positives. However, our solutions can't be less than negatives, and they can't be equal to negatives. So this right here would be considered a no solution. Okay? Versus, say, a problem like, let's take a look at number 30. Okay? So there's number 30. Tell your neighbor the first thing you have to do on number 30. All right. Volunteer? Someone that hasn't participated yet today? You've already had in community? Yeah? Cool? Yeah, move the 5. So we'll subtract our 5. Okay? So we're left with the absolute value of 3m minus 2 is greater than negative 3. Can an absolute value be greater than a negative? Yes. In fact, when is it not greater than a negative? Is it ever not greater than a negative? It's always going to be bigger than negative 3. It has to be. By definition, an absolute value has to be. Anytime you have a greater than symbol, if it's greater than a negative, this is infinitely many. Okay, so you have two kind of special cases here. You have when you had the absolute value being less than a negative. That's a no solution. We know an absolute value can't be equal to a negative. That's a no solution. However, if it says an absolute value is greater than a negative, that's infinitely many solutions, because it's always greater than a negative. So we want to think through these logically and think through the different types of problems, different types of situations that you have. Think through the statement as a logical statement, okay, versus just kind of looking at the numbers and trying to remember those little rules. Read it like a sentence. Absolute value greater than negative, that's always true. That's infinitely many. Okay, the other two problems on this, I'm not going to do them, but the other kind of different ones that you're going to see, problem 31. Okay, and problem 36. All right. 31, you should be asking yourself, what numbers are 0 units from 0? This is not a no solution, by the way. Okay. And here you should be thinking, well, that looks a little different. Why does our absolute value look different here? Compare it to every other absolute value on this page. Yeah, the variable's not in that absolute value. So we know the absolute value of 7. What is it? No. What's the absolute value of 7?
7 negative 7.
It's 7. Is it negative 7? How far away from 0 is 7? 7. Okay, it's just 7. All right. That's kind of a different one. All right, so I've shown you the special cases. Keep asking if you have questions.